Hello mathematicians, today is lesson 2.1, which is about symmetry in shapes. So as always, we'll start with our objective. I can explain the difference between reflectional and rotational symmetry and identify shapes that have one type of symmetry, both types of symmetry, or no symmetry. So we're actually going to do two things besides talk about symmetry. In our class, we are using a new notebook for Unit 2. So we're going to need to download that first, and I'll show you how in this video. And then we'll talk about symmetry itself using our notebook. I'll show you exactly what you need to be writing in your notebook, and hopefully we'll learn about symmetry along the way. So first, we are going to download our new notes. So let me go to our Canvas page, and I'm using second period as an example, but these steps should be the same for whatever class you're in. Before we move on, now that we're here, I would like for you guys to do me a favor. If you're watching these videos, I want to know what you think about these videos. So please fill out the video lesson survey up here at the top. There is a link that'll take you to a Google form. I just want to know what you guys think about these. Your feedback is important to me because you're the ones using these videos. So I would definitely love to know what you guys think. How can I make these better? Which type of videos would you guys prefer? So go ahead and do that. But for now, we're going to continue with our lesson. So we're going to click on modules. Now under modules, the one at the very top, and again, this is for all classes. You all have the same modules. You'll have the notes module. You go down to the bottom of the notes module, you'll see Unit 2 notebook pages. This is the one that we're going to open. So click on that. Then you'll click on Unit 2 notes, and it'll ask you to make a copy of these notes. I'm going to click on make a copy. And so now I have the notes. What I want you guys to do in these notes is first, you're going to change the name of these notes. So you can erase copy of first name and write your first name. I'll put Mr. for my first name. And then you're going to erase last name and put your last name. And then whatever period that you have. I'm going to put video, since these are the notes that I'll use for my videos, but you will put whatever period that you have me for class. And that's it. The next thing that I want you to do is to move these notes into your notebook folder. So I want to click on the folder icon here so that I can move these notes. And it should already start you on my drive. So you'll scroll down and find your geometry notebook folder. And you should have your first name, last name, and your period. If you don't have a folder, I want to show you how to make one directly from here. So if you don't have this folder, you're going to click on this icon right here. And it's going to create a new folder. You're going to need to name it. So you're going to name it in this style, this format. You're going to put your first name. I'll put my first name, but you need to put yours. And then an underscore, and that's not an underscore, that is. Then put your last name, and then your period. Again, I'm going to use video, since I'm using these for video. And then another underscore, and then you'll put geometry notebook. Click on the check mark to create your folder. And then finally, when your folder is made, just click on move here. Now, if you just made your folder, you're also going to have to do another step that I'm going to show you right now. If you already have your folder made, you can skip ahead. This is the video after all. You can skip ahead to the actual notes for symmetry. You don't need to watch this part because you've already done this in class. But if you have not shared your geometry folder with me, you just made it right now, just finished making it, then this is what you're going to do. We need to go to our Google Drive. So you're going to open a new tab and put google.com. Well, in a Chromebook, it should already open it on Google. You're going to click on the square up here at the top, right-hand side, and then you'll click on Drive. You might need to look for it, but it's there. Click on Drive. And now you're going to look for the folder that you just made. If you scroll down, you should find it. And, oh, here it is. That took a little longer to find. Well, anyway, so you're going to click on it once, and it's going to be outlined in blue like this. It's going to shade blue, the letters are blue. And then you're going to come up here to the little guy with a plus sign next to him. Click on him. Click on that, and this menu will pop up. You're going to do two things. First, down here where it says Get Link, you can click here where it says Change Link to San Antonio Independent School District. If you click on that, it should now say San Antonio Independent School District instead of Restricted. So that's the first thing. Make sure this says Viewer. And then you're going to come back up to Share with People and Groups. Click on that. Then here, you're going to type my email address. It's RGARCIA44. RGarcia44. Click on me. Click on my ugly face. Make sure that it says Editor here on the side. And then you can click Send. So now your geometry notebook folder should have a little guy inside it. That means that you have successfully shared it with me. So now let's go back to our notes. So in this unit, I'm going to zoom in. We're going to be talking about symmetry, rigid transformations, non-rigid transformations, and composition of rigid and non-rigid transformations. We're going to talk about what all of this means later on. But for today, we're only going to be looking at symmetry. So on page 2 of our notes, here are the notes on symmetry. So to start, shapes can have one, both, or none of the following types of symmetry. The first type is reflectional symmetry, which means I can flip a shape or I can fold it across a line of symmetry and it'll still look exactly the same as the original. So for example here, and you can do this in your notes too, I can actually drag this arrow around and it'll bring the outline with it. But the shading of the arrow, the red, is still there. It's still in its original position. So this will help me see whether I have reflectional symmetry here or not. So one way that I can check reflectional symmetry is to flip this shape and see if when I flip it, it looks exactly the same as it did. So for example, if I right click on this arrow, and if you're on a Chromebook, you'll need to press both of the trackpad button at the same time, and that's right clicking there. Or you can also come up to Arrange and then Rotate. But you're going to find these two options, flip horizontally and flip vertically. So again, that's Arrange up here at the menu bar and then Rotate. If you right click on the shape, then it's right there where it says Rotate. Now I'm going to flip this vertically, meaning that the top will go to the bottom will go to the top. And you see how my shape changed. And you also see that it doesn't line up. It doesn't match up at all. So that doesn't necessarily mean yet that this doesn't have reflectional symmetry, because we only flipped it one way. All this tells me is that I don't have a line of symmetry going horizontally, because I can't flip this over this line and it'll look the same. I can also think about it folding. If I fold the arrow right here at this line, this part in the red won't look like this part in the red up here. So there's no line of symmetry going horizontally. So let me reverse this back to the way it was. And now I'm going to try to flip this horizontally. So in other words, this point is going to come to the right-hand side. This point will go to the left-hand side. So I'm rotating it horizontally, and let's see what happens. And so what happens is it looks exactly the same. So I can flip this arrow horizontally, and it'll still have the same outline, the same shape, everything is still the same. If I fold this arrow in half this way, it'll still look the same. So that line where I can fold it and still look the same will be my line of symmetry. So let's draw that line. I'm going to make it black. I'm going to make it wider. And I'm going to make it a dashed line. And so here's my line of symmetry. Now we always need to be on the lookout for any other lines of symmetry. This red arrow has no more. There's no more lines of symmetry or no other ways that I can fold this arrow to look the same. So let's move on to the next shape. I have a blue star / diamond looking thing. So I want to identify the lines of symmetry here. And again, I can flip them. Let's flip horizontally first. And nothing changed. It's still the same shape. So that means we have a line of symmetry also going vertically here. I'm going to copy this line, Control C, Control V, and put it here. So let's flip this shape now horizontally. No, we just flipped it horizontally. Let's flip it vertically. And this time, the vertical flip does work. We have the same exact shape. So we can draw another line. Actually, I'm just going to copy and paste this one and move these points over. So we have another line of symmetry, this time going horizontally. So far I have 1 and 2 lines of symmetry, one going up and down, one going side to side, but there's more. There's more, right? Because if you think about this, I can also fold this line or fold this shape this way. If I fold it along this line, this point lines up with this point lines up with this point, so there's another line of symmetry. And in fact, I can flip that one around over, and I'll have another diagonal line of symmetry going this way. So in total, I have 4 lines of symmetry here. So I'm going to make a text box and type in 4 lines of symmetry. And I forgot to do this for the arrow, so I'm going to type it in over here too, or rather just copy and change this. This only has 1 line of symmetry. Now the reason why this is only 4 lines and not 8, some people may count these and they'll be like 1, 2, 3, 4, 5, 6, 7, and 8. Well, the problem is that if I count this line, this point up here, it's the same as this point because they're part of the same line. So we need to be very careful when we count lines of symmetry to make sure that we're not counting the same line twice. So one way to do that is if you're in Google Slides, you can hold down the Control button on your keyboard, and that'll select lines as you click on them. So I can click on the first one, and if I press and hold down Control and click on the second one, it'll keep both of them highlighted. So I know that I counted 2 lines, and I can continue. I got 3 lines, and then 4 lines. You see that all of the lines have been clicked, so now I know for sure that this is only 4 lines of symmetry. For the purple trapezoid here, let's try flipping it to see if I have any symmetry here. So I flip it horizontally, and you see the issue up here, right? It doesn't line up. Even if I try moving this trapezoid around, it's not going to line up. So why don't we try bringing that back and flipping it vertically now? And again, it's not going to line up. So we can say that this purple shape, it has no lines of symmetry. So I'm going to make a text box here, and I have no lines of symmetry. Now the condition for not having any reflectional symmetry is that there are no lines of symmetry. So because I have no lines of symmetry here, I can also say no reflectional symmetry. Let's move on to rotational symmetry. And again, if you need to copy this, you can always pause the video, make your copy, and continue. So with rotational symmetry, the shape can be rotated and match the original shape. The number of times that it matches up, including when it returns to its original position, is called the order of symmetry. So this time when we count how many times it matches up when it rotates, we're counting the orders of symmetry. Let's take a look at this yellow flag-like shape. Now in Google Slides, you can rotate a shape by clicking and dragging this point that connects to the main shape with a single line, like this. If I rotate it, the cool thing is that it also shows me how many degrees I've rotated it so far. So let's try rotating this shape to see if it ever lines up with itself. So as I go, hasn't lined up yet, but over here at 180 degrees, it lines up. So far I have one order of symmetry. Let's continue spinning to see if it lines up again. Now I'm rotating it, and it didn't line up. Again, now we're back to its start. But even going back to where it started counts as an order of symmetry. So here, with this shape, I actually have two orders of symmetry. One where it matched itself at 180 degrees, and one when it got back to its original starting point. So here, I'll type two orders of symmetry. Let's take a look at the star next. And again, I'm going to rotate this star and count how many times it lines up with itself. So I start spinning it, you can see my degrees there. And I have it matched up once here, which is at about 60 degrees. So let's keep going. Here it lines up again at 120, at 180, at 240, at 300, and then we're back to start. So that was 1, 2, 3, 4, 5, and then back to start is 6 orders of symmetry. So I want to copy this and just bring it over and change this to 6 orders of symmetry. Now if you look at the teardrop shape, it's pretty obvious, right? It's not going to match up with itself at all until we go back to start. See, I rotated, it never matched up until I got back to where I started. So I can still say that this shape has one order of symmetry. And I'm going to write that in a text box here, one order of symmetry. Now earlier, we said that if a shape has 0 lines of symmetry, then there is no reflectional symmetry. Well, saying that a shape that has one order of symmetry is like saying that this shape has no rotational symmetry. Because every single shape, no matter how crazy or whacked out it looks, is always going to have at least one order of symmetry. So that's not something unique. That's something that all shapes have. So it's nothing special if you have only one order of symmetry. So we can say that shapes that have one order of symmetry have no rotational symmetry. Down here at the bottom, I have a link that'll take you to a different page, but it'll let you play around with different shapes and see how many orders of symmetry it has and how many lines of symmetry it can have. You click and drag this black dot, it changes the type of shape that you have. You click and drag the green dot, it shows you what it looks like when it's rotating. You can count the orders of symmetry here. And if you click and drag the red dot over here on the right hand side, you can move the line of symmetry to see if this shape has any reflectional symmetry. And you see that this one does. In fact, it has both types of symmetry. It has reflectional and it has rotational. So that's pretty awesome. But not all shapes are going to have both types of symmetry. For example, let's say this shape right here. If I rotate this shape, you see that it matches up here, right? So that's one order of symmetry. So we know, and here it matches up again. So that's two orders of symmetry. So we know this shape does have rotational symmetry. It has 4 orders of rotational symmetry. But if I go and find the lines of symmetry, if I rotate this line around, it never matches up with itself. So this shape has no reflectional symmetry, but it does have rotational symmetry. So that's a pretty neat little tool that you guys can use. And again, it's at the bottom of your notes for symmetry. Well, that's it for today's lesson, guys. If you still have questions about this, please hit me up. Please let me know. Send me a message on Canvas. Send me a message on Remind. Please let me know if you have questions. Don't forget to do your assignment on symmetry, and I'll see you guys next time. Have a good day.